Am I audible, students? Okay, actually today I'm having a weak connection, weak internet connection. So question number 9, that find the directional derivative of f of x y, that is x e raised to y plus cos xy at the point 2 and 0 in the direction of vector a is equals to 3i minus 4j. So this is the question. First of all, let us find a gradient. So gradient of f, nebula f is equals to I del by del x of the function. Please see the definition of a gradient, plus j del by del y of given function. Okay. So we have I, partial differentiation with respect to x. So x becomes 1 and we have e raised to y. Cos theta gives minus of sine theta. Again of x and y with respect to x is y. Again of x and y, x into y with respect to x. So it is 1 and we have y. Similarly, now we have partial with respect to y. So x same of e raised to y is e raised to y. Again we have minus sine xy. Again of x into y with respect to y is x. Now let us find this gradient at point 20. At point 20. So in place of x, I'll put 2. In place of y, I'll put 0. Okay, this is what we have. Where we have 2 and 0. X is 2, y is 0. So y is 0. Here y is 0, so that term will be 0. Plus j, x is 2, y is 0. X is 2, y is 0. And that is why e raised to 0 is 1. We have I plus j, this is 2. And sine 0 is 0, 2 minus 0, such that we have I plus 2j. I plus 2j. So please note down, this is first part of question number 9. We derived this nebula phi. We are done with nebula phi. And now we will find a cap. We will find vector upon magnitude. So please note down, students. Okay. So now as vector A is equals to 3i minus 4j, 3i minus 4j, its magnitude is square root of 3 square, coefficient of I, and of minus 4 square, coefficient of J. So we have 9 plus 16. So magnitude is equals to 5. Okay. And hence directional derivative nebula function dot vector upon magnitude. This is the formula. So vector is 3i minus 4j divided by magnitude is 5, divide by 5, and our nebula phi is I plus 2j. So we have I plus 2j. Okay. So this is I plus 2 times j, 3 by 5 I, 4 by 5 j, dot product of two vectors. I square 1. So we have 1 into 3 divided by 5, plus minus minus. J square is 1. So we have 2 into 4 upon 5. So this is simply 3 upon 5 minus 8 upon 5. 3 minus 8 is minus of 5 upon 5, and that is minus 1. Please note down, please write it down. And let me know if you have any query, any question. Please let me know if you have any query, any question. Okay. See question number 10. Okay, before that, question number 11. I have left two questions because both are similar. Okay. So first of all, let us see 11 number question. Once you understand the concept very well, then we will see those two questions. No worry. So function is t is equals to xy minus yz. It is minus. So minus of yz plus zx. Point is 0 and 0 in the direction of vector A. Sorry, point is 1, 1, 1. Point is 1, 1, and 1 in the direction of 3i minus 4k. So first of all, gradient of function t, that is a nebula t. So I del by del x of function plus j del by of a function plus k del by del z of a function. Partial with respect to x will be y plus z. Partial with respect to y will be x minus z. And partial with respect to z is x minus y. This is minus y and then it is x. So x minus y. Okay. Now let us put x, y, and z is equals to 1, 1, and 1. So nebula T at 1, 1, 1 is I1 plus 1, J1 minus 1, K is again 1 minus 1. So this is simply 2i. It is simply 2i. As a vector A is equals to 3i minus 4k, its magnitude of a vector will be again 3 square, 4 square, so it is a 5. And hence directional derivative nebula T dot vector divided by its magnitude. And hence here we have nebula T is equals to 2i, vector is 3i minus 4k divided by magnitude. So it is 2i dot product with 3 divided by 5i minus 4 divided by 5k. So I into I square. So it is 2 into 3 upon 5 minus, here we do not have coefficient of k, and this is 4 upon 5. So it's 0. We have 6 divided by 5. Directional derivative is 6 divided by 5. Please note down, take a screenshot. Let me know if you have any doubt. Okay. See students, fourth question is remaining. Now 9 number is done. 10 is remaining, 11 is done. Let us see 12, 13, and 14. Question number 12. Function f is x cube xy square minus z. Point is 1, 1, and 0. Whereas direction vector A is 2i minus 3j plus 6k. So this is the question. Find a directional derivative. So first of all, we will find gradient nebula f. So I del by del x of a function plus j del by del y of a function plus k del by del z of a function. Partial differentiation with respect to x. Now with respect to y will be minus x into 2y. And with respect to z, partial differentiation is simply minus 1. Partial with respect to x, y, and z respectively. Now let us put a point in a gradient where point is 1, 1, and 0. So x is 1, y is 1. This is minus j 2, x is 1, y is 1, minus a k. So we have I, 3 minus 1 will be 2, minus 2j minus k, say 2i minus 2j minus k. First term. Now, as a vector is 2i minus 3j plus 6k, magnitude will be square root of 2 square minus 3 square, 6 square. It is square root of 49 and hence magnitude is 7. Such that directional derivative is nebula f dot vector divided by magnitude. So we have 2i minus 2j minus k dot product with vector 2i minus 3j plus 6k over 7. Okay. So that we have 2 into 2 by 7, 2 by 7 minus minus plus 2 with 3 by 7 minus plus minus 1 into 6 by 7. Just to simplify it. That will be the required directional derivative. Please let me know if you have any query, any question. Okay, let us see 13 number. That function g of x, y, and z is equals to 3 e raised to x cos yz. Point is 0, 0, 0, and vector is 2i plus j minus 2k. So this is our question, and we are asked to find directional derivative. So first of all, gradient nebula g, I del by del x function plus j del by del y plus k del by del z is equals to I partial with respect to x of e raised to x is e raised to x keeping cos y z is same. Now with respect to y, so keeping 3e raised to x is same, 3e raised to x, where cos becomes minus sine yz, again of yz with respect to y is into z. Similarly, 3e raised to x is same, minus sine yz, but now of yz with respect to z will be y. Point is 0, 0, 0. So nebula G gradient at 0, 0, 0 is I 3e raised to 0 cos 0 plus minus j 3e raised to 0 sine 0, and this one is 0 plus minus k e raised to 0, again sine 0 will be 0. So this is I 3 e raised to 0 1 cos 0 1, and that is 3i only. This is 0 and another 0. Okay, vector is 2i plus j minus 2k, and hence magnitude is square root of 4 plus 1 plus 4, and that is 3. Let us find directional derivative. So directional derivative, nebula G vector divide by its magnitude. So nebula G is 3i, vector is 2i plus j minus 2k divide by 3. So just multiply coefficients of I, 3 with 2 by 3, and hence we have 2 only. Please note down. Let me know if you have any doubt. Please note down. Okay. Let us see 14 number question. That function is 4xz cube 3x square y square z. Point is 2, -1 and 2, and vector is 2i plus 3j plus 6k. Gradient I del by del x plus j del by del y plus k del by del z of a function. So partial with respect to x, 4z cube, this is 1. Here we have 2x into 3 will be 6x y square z plus j. With respect to y, this is a 0. Y square becomes 2y into 3 will be 6 x square yz. With respect to z, it becomes 3z square. So 3 into 4, 12, z square, x same. Z becomes 1, so 3x square y square. Now putting this point, so nebula 5 gradient at 2 minus 1 2, z is 2, x is 2, y is minus 1, z is 2, plus minus minus 6, x is 2, y is minus 1, z is 2. Then we have 12, x is 2, z is 2, x is 2, and y is minus 1. Let us simplify. 8 into 4 minus, this is 6 into 2, 12 into 2 will be 24, minus of j, this is 4, 4 into 2, 8, 8 into 6 will be 48, plus k, 12 into 2, 24, 24 into 4, 56, minus 2 square 4 into 3 will be 12. So we have, this is 8i, 48j, and here I'll get, this is 4, and again 44k. Vector is to y plus 3j plus 6k. So its magnitude will be 2 square, 3 square, 6 square, half, and that is a 7. Okay, please note down so that I can move to the next slide. Okay. So directional derivative, nebula phi dot vector over its magnitude Our nebula phi is 8, 48, 44. 8 minus 48 and 44. Coefficients are I, J, and K. Dot product with 1/7 is magnitude, where vector is 2i, 3j, 6k. 2i, 3j, and 6k. So 8 into 2/7, coefficients of I, minus 48 into 3/7, coefficient of j, plus 44 into 6/7, coefficient of k. Simplification is the directional derivative. So this is question number 14. Please note down. Now let us see those questions which we left. I think 2 questions we left. So let us see those questions. So question number 4, equally inclined with coordinate axis. So that you can be able to solve a 10 number. Angle is already given. Okay. And we'll see. So 12 is done. 13 is done. 14 is done. I'll see 15 to 20. Before that, I'll see 4th one. Okay. See question number 4. Function is x square, y square, z square. Point is 1, 1, and minus 1. And vector is equally inclined with coordinate axis. And that is nothing but cos 45i, cos 45j, cos 45k. That with coordinate axis 45 degrees equally inclined. सभी एक्सिस के साथ same angle inclination, that is 45. And in a vector we usually consider cos function. So it is cos 45i plus cos 45j plus cos 45k. 1/√2 I, j, and k will be vector A. Okay. Let us find its magnitude here itself. So it is simply square root of 1/√2, 1/2, again 1/2, 1/2. So it is 3 times 1/2 √3 divided by √2. 3 times 1/2, so it is √3 divided by √2. We have function phi is x square y square z square. So nebula phi is I, partial with respect to x, 2x y square z square. With respect to y, so 2y, rest same. And with respect to z gives 2z, x square y square same, and 2z. Okay, let us put that point, given a point 1 1 minus 1. So we have I 2 1 1 minus 1 plus j 1 1 minus 1. I am putting x y z 1 1 and minus 1 respectively, nothing else. 1 1 and minus 1. Okay, so it is 2i, then plus 2j and negative of 2k. This is nebula phi at a point, nebula phi. Therefore, okay, take a note of it. Take a note of it. And let me know if you have any doubt. Okay, so we have gradient and vector with magnitude. So directional derivative is nebula phi dot vector upon magnitude. This is 2i plus 2j minus 2k. 2i plus 2j minus 2k, nebula phi, dot product with vector A. So it is 1 by root 2 I plus j plus k. Okay, I've taken 1 by root 2 common. And we have root 3 divided by root 2 as magnitude. So we have 2i plus 2j minus 2k, 1 by root 3 I plus j plus k. Coefficients of I 2 and 1 upon root 3 respectively. Here again same, and these are negative, 2 and 1 by root 3. So cancel and we have 2 divided by root 3. Please note down, this is directional derivative of a 4 number. Question number 4. Question 24. Okay, sure, we will see. We will see. Okay, so and note down this question number 4. So we are done with 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is now in homework. It is a similar one. It will be in homework. Makes an angle of 30 degree. So your vector will be cos 30i, cos 30j plus cos 30 of k. Okay. So this is in homework. So 8, 9, 10 is in homework. 11, 12, 13, 14 done. And what is 24? Okay, Vishwajit, simply find its curl. If it is irrotational, so simply find curl. If curl of this vector, V, or say curl of R of T is 0, then it is irrotational. So simply find curl, nothing else. In a 24. Okay. Okay. Uh, so 15 is a scalar potential function. Scalar potential function. 20 scalar potential function. We will see later on. Scalar potential function. Okay. So now we will see question number. Divergence is done, curl is done, A is done. So here remaining questions are 15, 16, and 20 that we will see later on. So we'll see 22 directional derivative, 23 directional derivative, 25, and we'll see gradient. Okay. Let us see 22 number question. Question number 22. Find the directional derivative of function f is equals to xy plus xy square plus z square. It should not contain ijk. Okay, in a 22 with xy here in a question I is given, whereas in a question with z square k is given, which shouldn't be. यहाँ पे I दिया गया है, यहाँ पे k दिया गया है, जो नहीं होना चाहिए. Okay, this is all about the surface integration. Let us leave it right now. It is yet to be discussed. Okay, so questions of directional derivative are done. Questions of directional derivatives are done. Is there any doubt in any questions of directional derivative? Is there any doubt in any question of directional derivative? Okay, Janil, Prithviraj. Okay. Now see, 25th is f is equals to x square sine 2y. Point P is 1 and pi by 2. And direction is 3i minus 3j. Okay, so 25th homework, function, point, and direction, directional derivative. 25th homework. 26th, function is log of x square plus y square plus z square. Find gradient nabla phi del by del x of function del by del y of a function and k del by del z of a function. So this is 1 upon simply x square plus y square plus z square into 2x, 1 upon x square plus y square plus z square into 2y, and 1 upon x square plus y square plus z square partial with respect to z, 2z. At a point 1, 0 and minus 2. At a point 1, 0 and minus 2. So in place of x putting 1, y is 0 and z is minus 2. Okay, please simplify and let me know the answer. Putting x is 1, y is 0, z is minus 2, and let me know the answer. Okay, so it is 2 divided by 5i, 4 divided by 5k. Please verify, is it so? Vishwajit has the answer. Please verify it. Is it so, students? Okay. '27 number question is regarding directional derivative. So it is in homework. Now, is ma'am is done with scalar potential function? Is ma'am is done with scalar potential function? Okay, okay. So let us see 15, 16, and 20 number. So question number 15, 15 number. Find the scalar potential function of A, that is y square I plus 2xyj minus z square k. Okay. So first of all, find its curl. Find curl of A. So we have 3 by 3 determinant I del by del x, coefficient of I j del by del y, coefficient of j k del by del z, coefficient of k. This is curl. This is the formula of curl. So we have I partial with respect to y is 0, with respect to z is 0, minus j partial with respect to x is 0, with respect to z is 0, plus k with respect to y, and with respect to y is 2y, and with respect to x will be 2y. So this is 0, and such that vector A is irrotational. Vector is irrotational. Similarly, see, still few steps need to be do, but before that, let me do same steps for question number 16. यही steps हम question number 16 के लिए करेंगे, आपके लिए easy हो जाएगा इसलिए. So f is x square xy square I, y square x square yj. Find scalar potential function. So let us find curl of f is I del by del x, coefficient of I, j del by del y, coefficient of j. If we write k, we'll get 0, 0. So automatically it is a 0. And if we solve in this way, with respect to x will be 2xy, and with respect to y will be 2xy. And therefore vector f is irrotational. Similarly, let us see few steps of question number 20. Okay, find scalar potential function of f is equals to 2x yz I plus x square z 2y j plus x square y k. Find scalar potential function. So let us find curl of f I del by del x coefficient of I, j del y coefficient of j, k del by del z coefficient of k. 3 by 3 determinant. So this is I with respect to y x square, with respect to z x square, minus j with respect to x 2xy, with respect to z is to x and y, plus of k with respect to x 2xz, and with respect to y 2xz, that is 0, such that vector f is irrotational. If any vector is irrotational, that vector is equals to gradient of f. Vector is equals to gradient. This is the formula. So here f and f, so let us consider it as a phi, gradient of a phi. F is irrotational, so f is equals to gradient of a phi. A is irrotational, so A is equals to gradient of phi. Okay. So vector A, y square I, 2xyj, z square k is equals to formula of gradient del phi by del x, del phi by del y, k del phi by del z. Function is x square plus x y square I, y square plus x square y j. So I del phi by del x plus j del phi by del y. As the left side doesn't contain k, I'm not writing third term. It is okay. And here we have 2x y z I x square z plus 2yj x square yk is equals to gradient del phi by del x, del phi by del y, del phi by del z. Okay. Now comparing coefficients of I, j, and coefficients of k to both sides. Comparing coefficients of I, j to both sides. Coefficients of I, j, and k need to be compared. Okay. So here we have del phi by del x is y square. Del phi by del y, coefficient of j, is 2xy. Del phi by del z is minus z square. So here del phi by del x is x square plus xy square. Del phi by del y is y square plus yx square. And in a third, coefficient of phi to both sides, coefficient of j to both of the sides, and coefficient of k to both of the sides. Okay. Now, in this step, we will integrate with respect to x. यहाँ पे with respect to x integration करेंगे. यहाँ पे with respect to y integration करेंगे. यहाँ पे with respect to z integration करेंगे. Just a minute, students. Just a minute. Just a minute, students. I am adding one slide in between each three so that we can complete that question. Okay, please give me a minute. Okay, can you see PowerPoint presentation again? Okay, okay. Thank you, Vishwajit. So I have added one slide in between. Again, as I said, here we will integrate with respect to x, here with respect to y, and here we will integrate with respect to z. See, left side becomes phi, phi, and phi for all. So we have phi is equals to something, phi is equals to something, phi is equals to something. If we integrate with respect to x, y square is constant. So y square into x plus constant 1. Here integrating with respect to y, so 2x y square by 2, 2x and integration y square by 2, second constant, and integrating with respect to z gives minus z cube by 3 plus constant number 3. Okay, and therefore such that phi is equals to phi is equals to xy square, this one xy square, and this xy square, minus of z cube divided by 3, this one minus of z cube divided by 3, and c1 c2 c3, that is the c only, is required scalar potential function. Let me discuss or do it for second question. Here we will integrate with respect to x, and here we will integrate with respect to y. Okay, so left side is phi to both of them. Integration with respect to x, x cube by 3, x cube by 3 plus x square by 2 y square, x square by 2 y square, with respect to y, y cube by 3, y cube by 3 plus this is y square x square by 2, y square x square by 2, constant 1, constant 2. So together phi is x cube by 3, this x square y square by 2, this x square y square by 2, and we have y cube by 3, c1 c2 is c, is required scalar potential function. Let me do it one more time. Here we'll integrate with respect to x, with respect to y, with respect to z. So we have phi is equals to something for each three. With respect to x, 2 x square by 2 yz plus c1. With respect to y, so x square and z both are constant. So x square z into y plus 2y becomes 2y square by 2 plus c2. And for third, integrating with respect to z, both are constant. So x square y z plus c3. Together phi is equals to, this is x square yz, x square yz, x square yz, x square yz, plus this y square only, so y square, and we have c1 c2 c3, that is the c, is required scalar potential function. Okay, this is question number 15, scalar potential function. 16, scalar potential function. 20th, scalar potential function. In a first step, prove that given function is irrotational. Prove that given vector point function is irrotational. Therefore, that vector is equals to gradient. Vector is equals to gradient. Then compare the coefficients of I, j, k to both sides. Compare. the coefficients of ijk both sides and integrate with respect to x, with respect to y, with respect to z. Let me repeat it again, that first of all, prove that given vector is irrotational. If it is so, if irrotational, then vector is equals to gradient. Vector function is equals to formula of gradient. Compare coefficients of I and j to both sides, and then integrating with respect to x, integrating with respect to y. See it one more time. To find scalar potential function, first of all, prove that given vector is irrotational, therefore vector is gradient. Vector is equals to gradient. Comparing coefficients of I, coefficient of j, and coefficient of k. Integrating with respect to x, with respect to y, and integrating with respect to z. So this is integration with respect to x, with respect to y, with respect to z. So this is a scalar potential function. For second question, integration with respect to x, integration with respect to y, and this is a scalar potential function. And integration with respect to x, y, and z, hence it is a scalar potential function. Take screenshot, read steps one by one, and let me know if you have any doubt. We are done with assignment number 3. We are done with assignment number 3. Okay. Now you will do question of scalar potential function. Remaining questions of scalar potential function. So it is the 21st and 24. Do 21st and 24 only. Twenty-first, 24th. Okay, meanwhile, give your attendance. ME students. Mechanical students. Auto students. Automobile students. Civil students. Chemical students. International as well as national. Students, can you see uh, the grades of your lab session for assignment 1, 2, and 3? Can you see grades? Okay, okay. So this is the scenario, students. This is the grades you are having right now for assignment 1, 2, and 3. Suppose Abhima Kadia, then he has done second assignment. First is missing. Okay. Arya, Darshan, and many students have not yet done. Nadira meet missing second number assignment. Okay. And third is not yet submitted by any of the student. Third number assignment is not yet submitted by any of the student. So at the end, I will follow this grade sheet for your term work, for your internal assessment. Okay, I simply will follow this grade sheet. So complete your assignment 1, complete your assignment 2. If it is done late, see here, Deep has done late. It is fine. It is okay in such a situation, but do it. That is it. My concern is do it. Okay. Total we have 6 number of units, 6 assignments, but we will do 4 out of 6. or you have to do 4 out of 6. We are done with first, second, third, and similarly now in upcoming labs we will see Green's theorem as assignment number 4. Green's theorem and line integration as assignment number 4. So out of 6 you have to complete, you have to submit 4 assignments. So please do it, please complete it. Okay, see, this is the status of the students. If your name is missing, does mean yet you have to join the Google Classroom. If your name is missing, then still you have to join Google Classroom. Okay, so any question, any query regarding assignment submission or regarding assignment 3? Any question, any query regarding assignment submission or assignment number 3? Okay, so that is it. Take care of yourself very well. Do take care of your family members as well. Thank you very much. This is it for this lab session. We'll meet in the next lab session. Thank you. A good day to all of you.